Okay, can see the full screen, right?
Yes.
Okay, perfect.
Yes, sir.
Uh, all right. Yeah, so thanks a lot for having me. My name is Ashay Arora, and I'm one of the co-founders of Encode, uh, and also one of the alumni at IIT Kharagpur Civil Engineering Department. So I'm really happy to be here. For today's presentation, I was like, how do you kind of communicate your journey of being a civil engineer and then going on to become an entrepreneur, and what else? What are the things that I faced as an entrepreneur? Um, so I titled my presentation as the entrepreneurial journey of a civil engineer. Um, so, like, just to go over the presentation, I would just describe a little bit about me, just give you a little bit of an idea of where I've come from and where I'm going right now, a little bit about Encode and the journey of the company. And then, since the topic relates to opportunities in civil engineering, I prepared a brief discussion on some of the topics which I have seen in the startup ecosystem around me, and in some of the competitions that we have taken part, and some of the agencies that we've been working with. Like, what are the different kinds of startups that are coming on? So anybody who's interested in pursuing entrepreneurship after being a civil engineer, or somebody who is not a civil engineer right now but they want to pursue an opportunity in civil engineering as an entrepreneur, what are the possible ways, or what are the possible fields that are being looked into from different standpoints of being commercialized and new technologies that are coming up. So for me, I graduated from IIT Kharagpur in 2013 with my bachelor's in civil engineering. In 2018, after my bachelor's, I went for my PhD at Arizona State University in the US. And I finished my PhD in structures and materials engineering in 2018. And that's when the dilemma hit me whether I should pursue an academic career or should I pursue a startup kind of lifestyle. And, I, at that juncture, I kind of made that decision like, it's, it's good. It's a risk that I was willing to take. So in 2018, me and my co-founder Matt, both of us, we co-founded Encode. Um, Once we kind of co-founded the company, then the task for us was to conduct some R&D. But in order to do some R&D, you need to get funding. So we started pitching in many, pitch competitions. We started applying for university level grants. We started applying for government grants. We started approaching investors and pitching to investors. In 2019, we received our first seed funding from a group of investors here in Phoenix, Arizona. Um, and since then, we've been kind of very active along the startup ecosystem. In 2020, me and my co-founder were both honored in Forbes 2020 30 under 30 list for energy. And as we are progressing in 2021, now I'm the CTO and COO at Encode, and we are looking to build our team, grow our team, uh, commercialize the technology, and bring it to market. Now, okay, so what is Encode? So it's me and Matt. Both of us are co-founders of Encode. We have our PhDs in structures and materials engineering from Arizona State University, and for the last uh, 15 to 20 years combined, we've been working together in developing newer materials and specifically newer construction or newer structural materials for the infrastructure industry. Um, Now, what is Encode by itself? So Encode, we consider ourselves as an advanced materials company, specifically based in clean tech, and we are trying to develop sustainable solutions for the construction industry. And our vision is that we want to solve the global problem of climate change by innovating and by creating newer materials. So on the right side, you would see one of the articles that we were featured in recently, um, when we were actually coating one of the buildings on our university campus over here with the Encode paint technology that we developed. and we were looking to reduce the heating and cooling costs with that paint technology that we developed. So, what is our innovation? So, I'll just give you a brief idea about what exactly we do at Encode. What are the materials that we are working with? What are we creating? So, first of all, whenever you're kind of looking for a newer technology or looking towards a startup, the first thing is you have to identify the problem, right? Identifying the problem is huge, and that probably took up a lot of the time for us. So for us, we identified that uh, there is a lot of money that people are spending on heating and cooling costs. So whenever the temperatures get hotter, your air conditioning demand increases significantly. Whenever temperatures get cooler, your heating demands increase significantly, which is up to the tune of 372 billion annually. And this is just a number that is being spent in the United States. So we thought, can we develop a solution to solve this rising cost of heating and cooling our buildings? How do we develop a new technology, newer material that can solve this problem? So that's when we developed our active insulation technology, where we are able to take existing materials. So anything that would go on the wall of your home or on a commercial building. So it could be a roof paint, it could be a gypsum based plaster, it could be a cement based exterior finish called stucco, or it could be the entire wall itself. So can we take these existing materials, which do not really have any functionality to them, and transform them into energy efficient materials? So typically, when you think of a paint, it's just an aesthetic material. You use the paint to make your home feel prettier, right? To make your home feel look good, but it doesn't have any other functionality to it. So can we embed a newer technology inside that existing paint so that it can become more energy efficient? So that was the concept of the active insulation, which we developed. And since 2017, we've been working on it, and we are developing it. And what we found was that by using active insulation, we can lower the global carbon emissions to the tune of 500 million metric tons, which is a huge number. And if you are in the clean tech space, you kind of know that buildings are a huge contributor to carbon emissions. And so with this solution, we are able to portray that active insulation as the green answer. You can reduce the carbon footprint of your building. You can save directly, you can save money on heating and cooling costs, and you can shift the peak load to off peak hours. So all of these are value propositions for different people in the industry. So if you're a homeowner, then you really want to save money on your air conditioning and heating bill. You want to save money on your electric bill. If you are a bigger company, if you're a bigger organization, or if you're a state or a country, you want to reduce the carbon footprint of the economy. So it kind of tailors or caters to multiple stakeholders in that aspect. So as far as the timeline for Encode is considered, what we did, so basically I met my co-founder Matt when I came to Arizona State University in 2013. We started working on developing this new product in 2017, started developing it in the lab, and then we kind of in our journey to commercialize it, we participated in several pitch competitions. There were a lot of opportunities that were available to us over here, where you could get funding through the university as well as through external investors. So we pitched that. We were one of the 42 startups that pitched in April of 2019 at the Rice Business Plan competition, which is one of the largest student startup competitions in the world. Then we presented at TiCon 2019 in May of that year, and we won the best elevator pitch award and some other award as well. Um, then towards the end of 2019, we participated in the Innovation Incubator, which is sponsored by Wells Fargo, and it's a public-private partnership where we were able to get significant amount of traction and significant amount of funding to develop our R&D, to do more research, and to kind of come out with a product that can be commercialized in the market. And then, as it was earlier, it was mentioned, Q4 of 2020 was when we were listed on the 50 to watch list, 50 companies in clean tech to watch in 2020 by the Clean Tech Group. So that's been Encode's journey so far. So we are kind of still in the process of testing our product and then commercializing it. So I would consider us as a early stage startup, which is still in the process of growing. Now, by looking at all of those things, someone might paint a very rosy picture that everything is, always good. Like once you start a company, it's all good. And uh, but so this is like the common perception. Like you start a company, you have a lot of enthusiasm, and then you keep going. You're happier. You make a lot of money on the way, and then you look cool. But it's not. That's a very highly regarded misconception. The actual journey has a lot of downfalls. There's a lot of pitfalls, and the actual journey probably looks something like this. So, you're going, and then you reach a high, and then you're really happy, and then sometimes things don't work, and then you start working from scratch again, and you try new things, and then you keep on trying, and there's a lot of anxiety at times. There can be a lot of panic situations that, oh my god, like why are things not working? And but then the whole thing, the entrepreneur mindset is to always keep going. So no matter what happens, as long as you trust in the vision and the mission of your company, and you trust that you can build that product, you can build that technology, uh, in the end, if you look at it in retrospect, everything would be worth it. While you're going through it, there are a lot of places where you need to find a lot of motivation on whether you want to really continue, because a lot of startups fail in their early stages. Not There's probably a statistic that out of 100 startups that would start, only 10% of the startups can sustain beyond 2 years. So it's kind of a high risk high reward game, but then there is always a learning which you cannot learn anywhere else. So in the 2 years that you would spend working on the startup, you may have learned a lot that you may not be able to learn working 5 years in a bigger company. All right. So now coming on to some of the opportunities in civil engineering, and this is, as I mentioned, um, being in the kind of ecosystem, especially with construction materials, structural engineering, I have seen and thought about several opportunities that are available to entrepreneurs. And the basic thing, what I would tell you is defining the problem. The most important thing, if you are considering to start your own company or go and work for a startup or invest in a startup, is how well is the problem defined. So I'm sure a lot of you would have heard this quote that given an hour, I would spend 55 minutes defining the problem and then 5 minutes solving it. Because as soon as you define the problem really, really well, you know what problem your customer is facing, then it becomes much easier for you as the entrepreneur, who is the problem solver, to come up with a solution to that problem. A lot of times we see that people do things the opposite way. They develop something really cool, and then they go and try to figure out what problem they can solve with this technology, right? What I would say is, the first thing is you need to talk to a lot of customers, talk to a lot of potential customers who you think they might be a customer, and ask them what problem they are facing. And once they are able to define that problem, and then once you are able to define the problem for yourself, that's when you spend your time and energy and effort solving that problem. So this is the problem that we identified. So these are two pictures of how a house was built. One is from 1877 and one is from 2019. Now, if you look at these two pictures, they are almost alike. So the problem that we figured was, the way that we construct houses has not changed in 150 years. The people are still using the same technology with minor changes. The same materials being used. Now, that is one of the problems. Now, what are the other problems? As if you're going to become an entrepreneur, can you identify a problem in your sector? Now, as far as new startups in civil engineering are considered, so these are some of the ideas that I just want to throw out among people. These 3D printing is going to be one of the major, industries where startups can provide a lot of impact for economical housing for providing temporary shelters in disaster prone areas. Structural health monitoring, there are some startups in structural health monitoring, but still there is scope for a lot of startups to participate in that arena where can you monitor our infrastructure is aging? Can you monitor whether a bridge is going to fall in the next 2 years and retrofit it before it falls? Right? Can you develop a solution where you can do that? Can you develop a remote sensing solution or a drone monitoring solution, something like that? Innovative materials can be, we're all looking towards climate change. Can we develop materials which are innovative and help us fight climate change? Can you develop carbon negative materials? Right? Some more, can you develop functional materials? So there's a lot of kind of, for me, as what I have seen, there's a lot of focus towards developing newer materials that can solve problems. Then in civil engineering, we also learn about transportation systems. So can we develop smarter transportation systems that can reduce congestion, right? So, and then retrofit technologies and things like that. So, I mean, I'm sure we'll have time to discuss more on these topics. Um, for all the people who are listening on this call, I just prepared like a short slide on the resources. If you're looking for opportunities in startups, the first two are the books that I actually read and some of the mentors suggested to me. So you can note it down and you can try to get a copy of these two books, which really helped me kind of streamline my thought and get a perspective on what a startup uh, looks like. How do you actually, is there a way, is there a disciplined way that you can start your company, that you can do something? And then some other kind of resources are usually you start with incubators and accelerators, and then you can participate in pitch competitions. Sometimes the government has a lot of the grants where you can apply for. And then if you are at a later stage, then you can always approach some angel investors and VC firms. And I'm sure we'll have more talk about this as well. And there's the last slide of my presentation. So this was a picture which I took when I visited the Facebook headquarters, and this is on their wall where it sums up a lot about how a startup works. There's lots of ideas, but can you focus on the one which can make the most impact? And as a startup owner, as a startup founder, your perspective has to be, be open to new ideas and be open to failure. Like you'll fail a lot of times, but fail harder. So that was the key takeaway for me from that picture. So yeah, well, thanks a lot for this opportunity, and then I look forward to any questions that you may have.
Thank you, Mr. Asay, for your interactive presentation and giving a brief on the topic. Now I would request Dr. Brajesh Dubey to present his view on the topic.
Thank you, Rohit. Great presentation, Asay. I'll not call you Dr. Arora. You are almost 16 years younger than me by graduating by graduating year. I graduated in
Thank you.
'97, and I was in Nehru Hall. I don't know which hall
Oh,
you were. So
I was in Azad, so
okay, so okay, so well. So Asay did talk about quite a bit of what I wanted to cover. Since I'm an academic who has worked with industries, I have worked in industry in India before becoming going for PhD. After my campus placement was in EIL, Engineers India Limited, so I worked here for 4 years. Then I went abroad and did PhD, and then I was in US, Canada since 2015. I came back to India. So and I joined my alma mater, and this is my hometown as well. So that's the reason it's very nice for me to be here. So today I'll share some slides. My slides will, for some of the students who have taken my class, some slides may somehow to be similar because see what because I do talk about these stuff in my class presentation as well. So let me start. Can you see my slides? Or not yet?
Not
Not
yet.
it.
Okay, present now. Where is that? Okay, now it's there. Okay. Okay. Now you should be able to see it. Okay, so I just wanted to talk about some big picture, like why this some of these newer opportunities in civil engineering, and also focusing mostly from environmental point of view. I am a environmental engineer, civil/environmental engineer. So I've been working in environmental field for last several years now. And as Ashay was mentioning about some of those clean tech technologies and global warming, climate change. So I will also use some of the similar buzzwords here, and then try to explain. And since there are quite a few students in the audience, so I thought I'll put some little bit of background as well. So some of you who have heard me before, you may have seen this slide before as well. I apologize for repeating it, but I thought that since there will be a newer audience. So why, in fact, when we talk about these environmental issues, see, we are talking about, for example, even if you look at the startup just Ashay mentioned about, why the startups are needed, why those kind of materials are needed. So if you look at, see, overall our picture is as a civil engineer, we build things. So when we build things, we use lots of materials. And when we make those materials, they have to be cleaner materials, sustainable materials. So that's where the market is going. That's where the future is. We cannot have business as usual. And so if you look at the Earth, which is 4.6 billion years old, and if you put that in a 24-hour scale, and why 24 hours? Because we are more comfortable with 24 hours. There is a 24 hours in a day. So if you put that and you see that for 1 second is your closer to 52,000 years. So, and humans, modern humans have came to this planet at 23, 59, 56 hours. So nothing really happens up to 18 hours. The first plant life comes, then the dinosaur comes and they go away, then human have come, and then probably human will go away after, or we don't know, maybe thousands of years, or 10,000, 20,000, 200,000, we don't know that. But anyway, but this planet will be there. So this planet will be there. And so if you look at that 4 seconds, we have used up so much of resources and produces so much of waste, we have produces so much of pollution. So this is a time where we need to kind of start looking at the newer way of doing business. So that's where the innovation, that's where the newer opportunity is there for all the engineering discipline, and in general for the economy, and especially for our civil engineering, because we do a lot of stuff. If you look at the different courses that you guys take, you cover everything from early morning to late evening. Whatever we use, there is an element of civil engineering there. So there is a concept now that we have to move from these linear model to become more as a circular model. And what is the circular model? Basically, try to have decoupling of economic activities from the consumption of resources. Just before this panel discussion, I was discussing a PhD research with one of the students where he is trying to recycle this aggregate. Which he was working with Professor Barai and Professor Bhattacharya, SK Bhattacharya, but he's doing part of the work with me as well, where we are trying to look at if we can recycle those aggregate, and what is the environmental benefit we are really getting out of recycling those aggregate, because that's how you will sell the technology. Say you develop some technologies, when you go to this venture capitalist, when you go to this like a pitch as well, you have to have an environmental angle these days. Without the environmental angle, the immediate question will be, okay, what is the environmental benefit? Is it a greener material? Is it a greener technology? Even if you go for a bigger, like infrastructure projects, for higher, like the World Bank, Asian Development Banks, and those all are asking for LCA studies these days, life cycle assessment studies, which is kind of a tool which can help us evaluate the circular economy potential. So now what is the circular economy is all about? There we are trying to reduce the waste and pollution. So if the waste and pollution were never created in the first place, many of you may have taken wastewater course. So from your wastewater treatment plant, you have that clean water, then you have the sludge. The sludge can be taken to some energy factory where you produce energy, you produce biogas. And if you, for a startup, if you can come up with some ideas of how to clean this biogas in an economical way, that will make you a lot of money today, because that's one area where biogas industries is struggling today. In Toronto, they have a very beautiful food waste to anaerobic digester plant. I was involved in part of the design of that plant. But with the lower of natural gas prices, they have to flare that gas, which is kind of very sad, because this cleaning of the gas is coming out to be more expensive than like buying the natural gas. So per unit cleaning cost is much higher. So we, and of course, if you look at the policy angles, will also all will be there. Gradually, probably it will become much harder to use fossil fuel. Then we have to look at the renewable energy and all that. But as of today, if we can come up with a technology which can clean this biogas in an economically like a sustainable way, that will actually make a lot of money. And same thing with how to do it now. We are going for the solar panels. A lot of solar panels are being used. Like if you have looked at even IIT Kharagpur, if you do a aerial like a drone camera shoot of IIT Kharagpur campus, you will find that we have solar panel on almost every roof. How to recycle those rare earth metals from those solar panels? Rare earth metals, they are called rare because they are not that they are not, the quantity is limited, and we are depending on China. We use rare earth metals for our batteries, we use rare earth metals in our cell phones. So it's to have, even from a material security point of view, we have to look at how to recycle those, how to get those critical material, precious material back into the economy, looking at from a secondary sources. So these will be like our secondary sources where we have to look at. And what if we build an economy that uses things rather than using them up? So we are trying to bring things again. So preserve. You try to preserve value in the form of energy, in the material. Make durable, reuse, remanufacture, recycle. Try to have material circulating in the economy. You cannot have downcycling. You have to have upcycling. Kind of. You have to have a value-added products coming out from there. There are some examples people are doing from the slag. They produce cement fertilizers, as roadside as cement fertilizers, roadside asphalt from the dust, some zinc and iron, process gas for electricity. So things are already working in this area. And we not only want to protect, but actually also improve the environment. Because see, I always say that in the class that we cannot have a healthy economy without having a healthy workforce. If our workforce is not healthy, if I have too much money in my bank balance, but if I cannot enjoy that money, there is no point having that money, isn't it? So, and that's where the society will move. In the Western, especially in the Western European countries, they are already kind of there. But the rest of the world will also start catching up with that, that we have to have cleaner water, cleaner air. And if you can contribute something in that area, that would be really helpful. And that will also can make you a lot of money too. So circular economy concept is started by the Swiss architect and industrial analyst, again from looking at the buildings and all that. He was trying to design out waste and pollution, keep the products and material in use. So we don't want to create waste, try to go towards what is known as the zero waste. So this diagram I just wanted to put there because if you are really interested about the circular economy and the opportunities related to circular economy in India, in the world, anywhere in the world, this is one place you should definitely go. Ellen MacArthur Foundation, they have a huge, very nice resource available there to learn about it and to look at newer opportunities there as well. Things are already happening. Say if you talk about these materials, in 1905 we used to use 4.6 tons of resource use per capita annually. 2005 it becomes around 9 tons, and in 2015 it says that 2 tons of resource use per capita is there in some in developing countries, but over 30 tons of resource use per capita in developed countries. So when we are using so much of resource, we cannot go to Mother Earth and try to get those resources. We have to start looking at the recycling part. So recycling in the construction industry, recycling from the waste management, recycling from the mining waste. So it's all those things has to be kind of electronic waste. That's another big area, like trying to do getting those precious metal recovered from electronic waste. Later on this year, we'll have Olympics in Japan, and all the metals that will be used there is actually extracted from electronic waste. So they have got all those precious metal recovery happening there. That also is a big, like in India, we are not able to do those precious metal recovery right now. We have to develop on some of these foreign countries to do it. So that's another opportunity that if we can have some homegrown technology being developed in India as well. 60% of India's population will live in urban areas by 2050, and 70% of the building that will exist in India in 2030 and 2030 is yet to be constructed. So that's a huge opportunity for us civil engineer to come up with greener buildings, more energy efficient buildings, use the product that Asay just talked about. I'm kind of doing a marketing for him as well. So apply this circular economy principle. So if we can do this, when we do this infrastructure, then it will bring environmental benefits as well as the social benefits. So that's what where we are looking at, and then will help us to achieve the sustainable development goal, several goals which is there, which we talk about in the class. I'll not talk to you more about that. This report came in 2015 by this framework of Indian Resource Panel, where it kind of talks about how our resource from different resources demand will be there in India. This is an India demand. So if you can look at, we have demand for fossil fuel, metals, non-metal minerals, and biomass. And it says that it makes it very clear that resource efficient production process, use of secondary materials, they are inevitable to meet both growing demand and supply constraints. So we have to look at those aspects. Then this report came in 2018, which is the World Bank report, which talks about different kind of waste, metal, glass, plastic, paper. So and then food and green waste. I call myself a garbologist. I've been working with different types of waste material for almost 20 years now. So as you can see, for each, this is another where we need the innovation today, especially in developing countries and in India. We know that these things can be recycled. We can do a lot of resource recovery from here, but still things are not working. And in terms of innovation, we also see, even I know that many of you are more interested in those robotics, artificial intelligence, machine learning. Those applications can also be here. We talk that about in our class as well sometimes, that even if we can have robots who can do this sorting for us, it is already happening in some countries, but then you have to tailor it. You have everywhere the waste is different. There is the nature of the waste is different, the working conditions are different. So if we can come up with some of those innovations where we can try to segregate this garbage, make those waste segregated so that we can do the resource recovery, try to have cleaner food and green waste for doing biogas, cleaning of the biogas. In fact, if you are interested in doing masters and PhD work, I'm looking for someone to work on this biogas. It'll coming up with low cost, clean tech technology on biogas recovery. Actually, I wrote this piece that in Economic Times almost 3 years ago, why this segregation is important. I'll skip this part a little bit because for the interest of time. Whenever we just very quickly, I'll say that whenever you go for these kind of stuff, especially if you are working, since we're talking about opportunities in entrepreneur, but even if you're working in, as many of you may become IAS officer or IAS Indian Engineering Services. So when you are on the regulator side, even if when you are a regulator side, when this budding entrepreneurs come to you, try to look at things from a systems perspective. Don't have that silos approach. Look at in a systems approach, look at the big picture, and let's try to solve the problem in total rather than just doing, of course, we have to do our piece, but we should not really lose the focus of the overall solution. That focus should always be there. And that kind of focus can be achieved by using the tool of life cycle assessment, which we talk about, where you look at from the cradle to grave, not even cradle to cradle, where you try to recycle the material back into the economy. identify the technology. When you try to look at technology, try to understand, as Ashay was also talking about, that we need to really do our homework. 55 minutes should go in try to identify the problem, then find, because once you know what needs to be done, how it was to be done, you learn a little bit from the courses. You can look at on different places as well. You can find that information, but unless you know what needs to be done, it's very difficult to find out the how part, isn't it? So in terms of what needs to be done, is that these are the hows, these are the different technologies how we can get there. But to identify the proper technology, we need to really understand the problem. And in especially since I'm talking most here, highlighting the waste management sector, which leads a lot of entrepreneurs in coming decades in India, especially. So where that what is actually trying to understand the garbage, what is really our problem, what is the problem that we are tackling, so that we can come up with one of these solutions and try to handle that. So it's a that is also it's very, very important. For example, I will say that we have been doing a lot of waste to energy in India these days for last a decade or so. But if you look at, we have around 69 megawatt waste to energy operational, but 66 megawatt non-functional. So these companies cannot sustain for a long period of time, isn't it? So we have to look at what is not working in an Indian context. So one thing you have to be look at that when you are trying to like import technology from overseas or wherever, you have to look at our local conditions too. Every technology is good as long as it has demonstrated it's useful in anywhere in the world, but it has to be Indianized, it has to be made localized as well. You have to tweak that to make it useful in the Indian context. You cannot just import technology all the time and try to make it use, especially in infrastructure related projects. So one example I'll give you, one of the this how like one area, if some of you are interested, if you want to partner with us in terms of, we are looking for, in fact I'm looking for some funding from some venture capital or DST and other places too, where we are trying to take this food waste and yard waste. We have so much trees on the campus, isn't it? So I thought all those leaves are falling, and those leaves are actually very good carbon material. So what we took those leaves and then did some pre-treatment where and then produced some biogas. The sludge, we made this hydrochar, and that hydrochar can be used as an energy. We can make pallets of those hydrochars and then sell it as an energy source to the other companies around here, or those whoever uses coal can use our hydrochar. It has similar calorific value as coal. And we are looking at the big like economics. We're trying to do the systems analysis for looking at socio-economic context and trying to develop this business model in terms of how we can take it to the market. So as you probably know that IIT Kharagpur recently started that lab to market cell as well. So this is one of the projects we have submitted there to kind of go from lab to the market in terms of coming up with the value added products. So you can use it as a fuel. You can use as an adsorbent or energy storage material. In fact, we have done some research on that, where we are submitting a patent on that as well, where this say food waste that you have produced in your hall, LBS hall or Triple M hall and all those big halls that we have, say 2 years down the line, the same food waste in a different form is in your cell phone now, because it can be used as a battery material. It could be a carbon material and can be used in the batteries. So those kind of work is going on, and that's a collaborative research. We're working with our colleagues from physics and other departments, the people working in material science and all that too. So this work that we have done has kind of made some news in the media as well, where some of you may have seen that. So that was more on talking about some of the work that we did and kind of big picture. Very quickly, I'll show you the other opportunity which is there in terms of finding a material which can replace plastic. Plastic, we use it so much, especially those single-use plastic. In fact, I was there as Asay was talking about those pitch session, and so I'm on the judge panel for National Geographic Society. So I was in Washington DC in December 2019, where many companies came and did some pitch, and then we selected few companies in terms of funding from National Geographic for their next stage. So those are all startups. So this plastic, how to get rid of this plastic, especially single-use plastic. So that's another big area. We are doing some projects here. We are looking at in terms of how this plastic is creating pollution in River Ganges all along. So we have done a lot of sampling all along, try to understand the problem. As I was telling, let's first understand the problem. What is really happening so that you can design a solution which will really work for it. So this was the team. This is led by a very old friend of mine. We did PhD together. This is Dr. Jenna Jambak, and then Heather, who is from UK. So you can see that it's mostly to, we are celebrating women success, isn't it? On March of 8th. This is an entirely woman-led team. This we are in minority, and I'm happy to be in minority there. So, and we were, but it was we have done the like a lot of work in the field in India. And the report is already there on National Geographic website. You can find it there as well. Then some work, we are also working with the World Resource Institute in the UK. We're trying to look at how to reduce the plastic pollution in ocean. This is another big area. You may have seen a big startup in this area. So if you look at those big startups, they have been focusing mostly on ocean plastic, and they are focusing on river plastic. But the problem starts in the land. From the land, the plastic is going into the river, and from the river, it is going into the ocean. So let's try to tackle this plastic from going to the river at the first place. Let's shut down the tap. If you can close the tap at the land itself so that plastic does not flow into the river, that will be a big help to this cause in terms of sustainable ocean economy. So we looked at all the different things which goes into the ocean, and then this was more from I would say, looking at from a policy point of view. And we came up with these different pollutants, then what could be the potential solutions coming out of that, and compared with the sustainable development goals. A lot of media coverage of that as well. So this is, so those are the work. Again, if you have interest in developing some value-added products from waste-related materials, so we are working on, so I already talked about few, but we are working on some more stuff from like biogas, biomethane, cleaning, upgrading, trying to biofertilizer. Then also in this area, along with colleagues from agricultural engineering, we are working on looking at trying to get this lactic acid to biopolymer, bioplastic, biomedical applications. So a lot of things can be done in this area. If you're interested, we are always, I'll be more than happy to talk about that. This COVID also created a lot of opportunities too. So especially in environmental field. So we have looked at some of the issues associated with COVID and environment, especially for waste management, for solid waste, as well as for plastic waste. And we are working in this area. You may hear from us something coming soon in future. So this is my last slide. See, whenever you try to look at the problem, see, this is here, this gentleman is driving a diesel car, and he feels so dirty because of all these things going out. He goes and buys an electric car, and he thinks that I feel so clean. But now what happened was this emissions moved from here to here, because we are still using coal-based thermal power plant, the fossil fuel energy for powering this electric vehicle. And also the batteries use a lot of rare earth metals, and if those rare earth metals are not recycled and we are going into the mines and creating newer material, we are also having a big environmental footprint there. So this is more of a problem shifting unless we fix all the other things associated with that rather than problem solving. So thank you. And again, I'll be happy. We'll take the question after at the end. So looking forward to interaction. Thanks.
Thank you, sir, for showing all the opportunities which are in the waste, also from the environmental point of view, also from the economic point of view. Thank you. Thanks a lot. And now moving onwards, I would request Dr. Lauren Ponson to share his view on the topic.
Hi guys, good afternoon everybody. Let me share my screen.
Yeah.
Up. Here, please confirm you can see the screen or
Not yet.
not yet.
Sir.
All right.
No, sir. Now we can see.
Yeah, you can see.
Yeah.
And right now.
Yes, it is visible.
Yeah.
Okay, wonderful. Okay, wonderful. So, first of all, thank you so much for the kind invitation. As you may know, I call you from Paris. I'm I'm a researcher and an entrepreneur also, located in Paris at Sorbonne University. It turns out I have a very strong connection with India. First of all, I'm lucky enough to work right now and to have worked in the past with a wonderful Indian student, and one of them is associated with this presentation, Ashwij, with my young colleague on the topic of failure prediction. And it turns out that it's Aditya Vasudevan, a former student of mine, who got me in touch with the panel organizers. Also, many colleagues in India, and I'm really looking forward for the end of the COVID to be able to visit them again in Kanpur, Delhi, and Chennai. All right, what I would like to talk about today is a bit probably personal and very interesting in respect to the first presentation, because I want to give an insight from a researcher, and I want to present a different perspective on entrepreneurship, how you can start from science to go to the market. That is called technological push, not starting from the market to find a solution. It's a different perspective, and I would like to share this experience with you. And as a matter of fact, I would like to talk about science also. And so let's start. So my field of research is material failure, and it turns out it's also a huge technological problem in many fields, including civil engineering. You may know that actually structural failure is still ubiquitous. And I took two examples to make not to avoid any jealousy. I took one example from France, one from India. Our airport in Paris, our main French airport, undergo a dramatic collapse like 4 years ago. Hopefully there was no one hurted. And the other example from the Indian civil engineering is a collapse of bridges. And you have a graph showing how the number of bridge evolve as a function of time, and you see that it's not a trend that is decaying. So material failure is actually a problem in energy, in transport is a huge problem. And rebounding on the second presentation is beyond the fact it can put in danger people. It's also a big ecological problem. We want to design a structure that can last longer, for which you can predict when you need to change them safely, and this problem, as a matter of fact, is not solved at all. So, what is a core scientific problem behind that? We think there are two problems. The first one is a design, and it turns out, we will discuss it later, that designing safe structure over a long period of time is actually a difficult challenge, still a difficult challenge from a technical perspective. The second pain is the lack of efficient tools of predictive maintenance, and we will discuss this also. So to share with you a bit of my entrepreneur experience, I'll not start right away by tools of design and predictive maintenance, but I will talk about Tortoise. That is a company that I launched 4 years ago, following a patent filed in 2014. And Tortoise is related to failure, but it's about the question about how do you explain a failure after it happened using fracture surfaces. It's also a very fruitful technology that ultimately will help to prevent failure. And I would like to spend a couple of minutes about this startup. So, as you probably know, when material fail, you may be able to extract information about the failure event to trace back the root cause of failure by inspecting the fracture surface. And this science is called fractography. It turns out that this engineering science is mainly done by carried by experts from either a visual inspection of the broken part or using scanning electron microscopy or microscope. But essentially, it's a qualitative technique. And we invented, 10 years ago, a technique that rationalizes this analysis that is explained here on this slide, where essentially you scan the fracture surface with a profilometer, you get the topography of the fracture surface that you can post-treat using proprietary algorithm based on the physics of failure, from which you can infer key information like the load at failure or the strength of the broken material. And ultimately, you can trace back the full history of a failure, come back to the root cause, and take decision about what you do next. Do you need to change all the parts that are looking alike? Do you develop a new maintenance plan? And you can even redesign the part in some instance. So the vision we have with this technology is that it's a kind of the DNA of material. You know that DNA has been very successful to solve crimes, and now it's used to a broad extent for characterizing live beings. And statistical fractography, that is the name of the technique we invented, can be used to explain failure, and to a large extent can be used systematically to characterize the mechanical properties of material, because it's very simple to implement. And so to give you a bit of idea of the time frame, we started Tortoise, as I was saying, 3 to 4 years ago. Tortoise is about 10 people today. It's about 1 million euro revenue, and I would say somehow Tortoise is somehow safe now. It's sustainable. It can now grow. And I would like to mention that we didn't raise any money, and I will come back on this point later. All right. So, but the main point I wanted to discuss is a new technology we develop in our lab, because they are more related probably to civil engineering. So and as you can imagine, explaining failure afterwards is obviously very important, but preventing failure before it happens is even more important. And to prevent failure, then you need to understand in depth what is the mechanism of failure of material. And I would say that the way we do entrepreneurship, we decipher, we understand the physics of problem we address to be able then to develop innovative technologies. And so I'll talk a bit about failure in civil engineering material like concrete. You may know that concrete, especially under compression, breaks under the accumulation of damage. It's not something like suddenly a defect activates and failure takes place. It's more a progressive and rather lengthy process. And there is a very interesting feature when you look at the location of the damage event that accumulate before failure. It's that, first of all, you can study them by acoustic emission. They take place by burst, and these bursts are telling you the location of micro cracks, and these micro cracks organize over time both in space and time to ultimately create a fault that will give rise to the failure of the material. And there are a very interesting feature that is known somehow in the literature, is that before final failure, you have a very intense acoustic activity that is a signature of this burst of damage activity. And the basic idea, as I will discuss in a minute, is how can you use these acoustic hits to be able to predict failure using statistical analysis of acoustic emission. Okay, there is a second topic I would like to discuss in parallel, is a consequence of the complex processes leading to failure of civil engineering materials, is the strong size effect. As you may know, going from the strength of a small structure to the strength of the same structure but 10 times larger is very difficult. And actually, there is no understanding and deep understanding of this process. And in our lab, we also were able, in collaboration with Ashwij, to understand this effect and then to help engineer, hopefully in the future, to design safer structure from small-scale structures. All right, so let me give you a bit of physics. At the end of the day, that's what counts very much when you want to have a. You need a. I would say I will finish my presentation by discussing particular points about entrepreneurship. I think, as a matter of fact, great scientific discovery lead to great innovations. And that's a suggestion I would make, to start by science. And so the simple idea we developed over years is that material failure is controlled by this feedback loop. Let me explain you a little bit what is this feedback loop. In the classical description of failure, and especially damage accumulation, you have this continuous vision that damage grows continuously over time. Actually, things are a bit more complex than that. And as I was mentioning, there is a strong intermittency in the growth of damage in material, and you can evidence it by acoustic emission. What is the physics behind? The physics behind is that if there is a point of the material that will break, and provoking a damage event, you will have stress redistribution within the structure, as damage event always lead to a local softening of the material. Essentially, at this location, the material is not able to handle anymore the same load as before. And this stress redistribution is spreading in the structure, is long range. And as you redistribute stress, you provoke a cascade of other damage events. That's this cascading phenomena that leads to this burst of damage activity that you hear when you do acoustic emission. And then you can start from this simple phenomenon and build the full theory of damage mechanics. It's what we did over years. And this theory of damage mechanics that takes into account the material disorder and the long-range stress redistribution is very powerful to describe not only localization process that leads to failure, but also to predict the burst activity and ultimately the acoustic emission of accompanying failure. And you see here the size of the burst as distance to failure, and failure being on the right. So you see this activity increasing in time. And this idea we capture in the theory works actually extraordinarily well in the experiments. And this is an experiment of Ashwij where a compressed cylinder of plaster, as you get towards a peak load where localization of damage takes place, you get this activity increasing. And from the model we developed, you can show that this activity of acoustic emission is actually following a very simple law. You can understand, we were the first one to understand from scratch with some kind of square root divergence of the activity or the size of the acoustic burst as you get closer to failure, where delta is the distance to failure, for example, in terms of force. Force at failure minus current force, or time at failure minus the current time. And you get this prediction from theory. You can solve numerically your model, and you actually observe a similar trend on this particular example, but it turns out that you can test 10 different material and rocks and mortar and so on and so forth, and this law is very robust. So what do you do with this law? I'm not going to go into the detail, but essentially you're going to use this law to predict the time at failure. And these are simple proof of concept where you're going to use the 400 second before, at the beginning of your experiment, the signal of acoustic emission, treat it using the idea that you expect a divergence of acoustic emission amplitude as function of distance to failure to predict the failure time. the failure time predicted is not so amazing. It's 450 seconds, so it's still 50 seconds before the 500 seconds where the actual failure time will take place, but it's conservative, and actually you can improve a lot. This prediction is just somehow a theoretical, a lab's proof of concept. So to show that effectively you can use the sequence of acoustic emission to be able to predict failure. Okay, what about the technological application? This technology is patented. It's still our lab. We're building a team to launch a startup right now. But what is the vision? Essentially, the vision is that we have a model that can predict the acoustic emission and the sequence of acoustic emission of any structure as function of time. And we call it acoustic numerical twin. Essentially, that at any time during the lifetime of a structure, you know what to expect in terms of acoustic signal. And so you can track the mechanical health of a structure by comparing the prediction of your acoustic numerical twin with actual experimental sequence of acoustic emission. That's the vision, to have a close surveillance of the mechanical health of structures. All right, let me say a couple of words about side effect. It turns out that the size effect, an example is given here on this slide, been largely studied in the literature. The size effect in compressive failure is that the bigger the sample, the weaker it is. Here you have a few points only for this experiment, but it has been largely observed in hundreds of different types of matter reaching a plateau at large size. That is a different behavior from tensile failure size effect. But whatever, what I wanted to say is that using the modeling and the simple idea of collective growth of damage due to this feedback loop in the stress redistribution, you actually can build a model that predicts this size effect. This is a theoretical curve. And it turns out that using this model, you can not only predict the failure strength, but you can predict the force displacement response, the mechanical response, as a function of the specimen size, as a function of structure size. And you can go from small to large, or large to small if you want, if you prefer, using this modeling. So as you can imagine, this is extremely useful for prototyping structure in the lab at small sizes to predict the behavior of large sizes structure. So there are other applications. I'm not going to discuss these two. These two technology are just patented, so it's the beginning of hopefully a long story. But the message I wanted to convey is that you may want to start from the lab to go to entrepreneurship, obviously, and great science very often make great innovations. The second thing I would like to say, I don't know how it is in India, but in France, people might be skeptical about the ability of scientists to be great entrepreneurs, and I think it's certainly not correct. And I would say that scientific background, research background, give you the opportunity to train as an entrepreneur, to take risk, to be innovative, to be able to convince people, to provide presentation. Obviously, you need to train on other topic, business especially, but if you have good scientific skills and good research skill of communication in particular, you can be a good businessman too. And I would say very simply that it's much harder for someone with a business background to go to deep tech than someone with a researcher background to go to this field. So go ahead. The third thing the first idea I would like to share with you and maybe discuss with you later is to focus on hard problems. There are so many startups that solve a little piece of problem, obviously in the digital field, application field. And okay, I believe to find a real game changer innovation, you need to focus on hard scientific problems that are very often hard technological problems, and that's where there is opportunity. There is also another thought I would like to share with you, very personal, but it really takes it's not a standard way. Also, at least in France, France entrepreneurship in deep tech is really seen as your ability to raise money, and I really would like to say it's not the only way. Here at Tortoise, for example, we focus on the market, not on the venture capital. This is very important to go very soon to the market for several reasons. When I say go to the market, means sell what you can sell as fast as you can do, and generally you can do it by not having maybe a final product, but to do consulting, to have a prototype. You have to find ways to do that. Why is it so important? First of all, you want to be free. You want to innovate, and you don't want to be constrained by a vision that is a financial vision of entrepreneurship. You want to be able to go on with your dream, to go on with your innovation, and I think the best way is not to be constrained by financial interest. That's my personal opinion. The second thing is that if you go very soon to the market, you're going to be pushed to urge to make a very good fit between your innovation and the needs of the market. And at Tortoise, we really start from the market, from the needs of the customer, to drive our product, to drive our R&D, to drive our innovation. And I think it's a very efficient way to make sure your product is going to fit to the market. All right, a couple of more personal thoughts, so I will be happy to discuss with you. I found the most difficult thing was not science or business, was to find good teammates in business. It's I had a chance to work with and to still work with wonderful former PhD students, postdoc, and we build teams. It's very hard to find more business partner, or this is a very difficult choice. When you take a partner, it's almost like, I would say, a wedding, and that's not an easy choice. So I just would like to say choose teammates with a lot of care. And then I would like to mention the fact, and I was very surprised of that. As you know, in science, there is a community of scientists that helps each other, interact through conference, and there is also a very strong and nice community of entrepreneurs, and you should never hesitate to ask feedback, help. Obviously, every project is unique. That's what makes the entrepreneurship journey so fantastic, but there are some patterns, and you can definitely get insight from other entrepreneurs. So I'll stop here. I'll give you my contact, and I'll be happy to interact with you, discuss with you later.
Thank you, sir, for giving your view on the topic and also showing the scope in the failure technology and for the current scenario, how much importance the failure technology is. And also, if the structure gets fails, then we have so much loss of the lives and realize the money. So it's really good. Now I would like to request Mr. Venkatesh Sitla for review on the topic.
Yeah. So see, that's the thing. When you're the last presenter, right? You have a little comfort. One, majority of it is already spoken. You're standing on the shoulders of the giants, right? Dr. Dubey, Dr. Ponson, Dr. Ashay Arora have already spoken. So my bit is a lot easy, being the last presenter. Let me do my best. Can you see my screen as well?
Yeah, we can.
So since I'm the last presenter, so let me keep the presentation very light. It's not going to be a very serious presentation. It's going to be more of an anecdotal, pictorial presentation. And firstly, let me take this opportunity to thank Professor Sen for his continuous guidance towards civil engineering society. As you can see, I myself was an office bearer of this society. I worked under Ashe. Ashe was our vice president then. I was a treasurer. You can see me and Ashe besides Professor Sen. And of course, part of this Megalith core organizing team back then during our time, which is the reason why we are all connected today, this evening. And let me also thank the co-panelists for saying yes and sharing their views and inspiring us and all our juniors this evening to be there in civil engineering and then to do great stuff. So let me begin the presentation and pick 3 keywords from the topic, which is the opportunities, civil engineering, and entrepreneurs. I'll pick 1 keyword at a time and then we'll go back and forth in each of it. So let me start with civil engineering, and trust me, I'm not going to teach you any civil engineering because you're good at it than me, but I will just thread my journey of civil engineering with you. So like you said, I've done my master's in structural engineering, and then I've decided to intern with Larsen & Toubro in India. And the first project I interned with was this Chhatrapati Shivaji Maharaj International Airport in Mumbai. And you could see the magnanimous project. The biggest challenge of this project was the runways, which you can see are crisscrossing each other, are actually operational all the time. And we were building this beautiful airport. And the biggest challenge was to keep it operational and then do this composed structural steel, which gave me a huge respect involving the complexity that it is in the heart of Mumbai, the city, and still be able to do it. After that, though I worked with L&T as an intern, but then I joined their competitor, Shapoorji Pallonji. That was the first company which came to the campus, and I've joined them as a structural engineer. And we were building this great building of a 7-star hotel for ITC in Hyderabad and a complex IT building for Novartis. And moving forward from there in 2016, then the renewable era has started in India. And you could see that, from the figures from 2015, the capacity addition of both wind and solar were doubling at a pace. And right now, from a standpoint, our country wishes to install 450 gigawatt of installed renewables in the power sector, in the grid parity, by 2030. And that's a long way journey. And I'll also show you where do we stand today. And you could see some dip in capacities. This is owing to certain GST and demonetization issues. But overall, the picture looks good. Solar, especially, that is the domain I work in. So speaking about it, right now, standing 31st December 2020, we have 42 gigawatt of solar, which has been commissioned into the grid. And an equal amount of capacity is in pipeline, which is under construction. And you could see certain dip, which is actually showing the true reality of the market, that during the lockdown where COVID has disrupted all businesses, there has been certain dip, and then slowly it's progressing towards its normal. And so what does a civil engineer do in a solar power plant? So I'll just give you certain cues that, the entire solar power plant is actually mounted on this structure, which is a cold form structure, which is steel. And then the foundation of the steel, again, which is a civil engineer's job to design it appropriately as per the site location and the wind speeds prevailing in that particular location. And traditionally, how it differs is that, in a building or other monumental structures, you're concerned that the foundation might settle down. And but in a solar field, while you're designing solar power plants, you're much more concerned about the uplifting or uprooting of the foundation rather than the settling of foundation. So this is how the cold form structure members look. You can see the modules or the core asset of the solar power plant being mounted on these structural steel members. So all your IS 800, IS 875, everything which you take it with a pinch of salt. While studying it, you feel the stress on the members is actually more on you than on the members of the steel. But truth be told, that these are all used in real life, not just in projects which are there in solar farms, which are huge in acres of land and everything. But then this solar is equally applied on industrial rooftops and also on your RCC buildings. Like Professor Dubey said, if you take an aerial photograph of IIT Kharagpur itself, you have a lot of solar being done on all your hostels and everywhere. And also there's this innovative area where even solar has been applied on water, which is called floating solar, where again the design of the structure of floating solar is completely different, where you're looking at buoyancy, and then even you don't want the plant to be floating all across the place. It has to be anchored, it has to be moved. There are techniques there, and how do you do that? So a lot of study and actual engineering goes into this. And this is a slide which I've put just so that, if you have to remember anything from this presentation, at least you would remember from this picture, which is a famous picture that, which shows off, signs of failure. So the core asset of a solar power plant is the solar module, and the entire solar module is actually being, held on the solar mounting structures, which is mounted, and if it is not properly designed, you would end up getting the entire asset at a failure point. So, for example, if you have not designed it appropriately for that particular location and wind speed, it so could happen the entire assets will come on its knees. It's not entirely every time it's the design problem, or sometimes it's so can happen that the quality of the material which is used, the manufacturing process in which it was made, all put together can lead to failure of the asset and the plant. So that's briefly civil engineering. Let me now talk a little bit on entrepreneurs and entrepreneurship. How Dr. Ponson has, towards his end, shared his points of view. And a small disclaimer before I go on, the content on entrepreneurship, how to be an entrepreneur and what to do, what not to do, is overwhelmingly large in the internet. You get to hear from VCs, the entrepreneurs themselves, but then let me emphasize or give you a context to the overwhelming content which is available on the internet. So the three things which I want to emphasize is, one, yes, spend your time, like Ashay said, like Professor Dubey said, that you need to spend time on the idea and the problem which you want to solve. The second point is the team, which Dr. Ponson said, it's equally important. What is the team which is going to work on? And then the third one would be product market founders fit. This is all jargon, but then in simple English, I'll explain in a bit. So I know my numbering, it should have been 1, 2, 3, but then that's the thing. It's 1.1 and 1.2 are actually interlinked. Let's say you think of an idea and a problem, and then you've decided this is the one that I'm going to work on. And once you start working on it, you realize that this idea does not have the potential or the scale of impact which you thought it would. So the ideas are really fluid. You work on them and then you realize, and then you have to reiterate or rescale, and then again relook at things. Similarly, the team, your co-founders, and then your initial first employees, all of them come together and then let's say they came together because of an idea which you convinced them that this is the idea and this is the problem which we are going to solve. But then let's say when you actually start working on the idea, and then you realize that this does not have the same impact of what you thought about it, and then when you hit a roadblock, and then you say, hey, maybe we need to take a U-turn and then reassess, find another path, or find an alternative idea maybe to work on. And let's say if the team says to you that no, it was the idea that is the reason I've come and joined this organization or this vision, and then suddenly if the vision changes, I'm no longer part of the team. So team and idea are two constant fluid things which keep evolving. As you start working on the idea, you get to know the idea. As you start working with the team, you get to know the team. And these two has to complement. The team has to be there for you even if the idea changes. So to get this perfect balance, you need to I'll explain what could be the other ways you can maybe have a solid team and an idea. So once, let's say, these two things have been figured out, you have the idea, you have the team, then this jargon of product market founders fit is basically in plain English, are you way ahead of is the product way ahead of its time, or is it too late, or is there big competition already existing in the market which is giving the services? So like Dr. Ponson said, you go to the market and then get feedback from the market and then take that inputs into your decision of how do you want to build the product and everything. And the other classic misnomer is that, once you're an entrepreneur, you're working as hard as you can. You're working 14 hours a day and at a stretch 7 days a week. But then the thing is, the idea is if you work that long at a stretch, you would not be that efficient. So the other way to look at it is, if you pull such long hours, you'll not be capable to giving that efficient output and also take that cognitive judgments on the product, on the market, etc. So it is actually you sprint on a problem, you go to the market, you take feedback, you rest a while, and then again sprint for the next enhancement of the product or on the better reach of the product, and then again rest. So it's going to be a lot of sprinting, but then it's going to be a marathon of sprint. It's not just going to be a simple marathon which you run. So one has to be careful on how they balance both the amount of work, rest, and you have to do it for a very, very long time. So, and the other great problem surrounding entrepreneurship is that a lot of noise surrounding funding is usually created when people say so many millions has been raised for so startup. So again, I'll not go into the details, but then let me give you just some context where again Dr. Ponson shared his own views that he doesn't want the VC's money telling you what should be the commercial outcome. So let me give you more context so that you understand what you're entering into. Let's say there's a point 0 to point A and B and CDE, which are equidistant, and then let's say they are 2,000 kilometers apart in physical distance. This could be 2,000 crores or anything, whatever metric you want to say, look at it. And what is classic entrepreneurship is, the entrepreneur comes and then says that this is the idea I want to solve. This is the amount of initial capital which I have. So let me put this capital and build the asset or the product. And let's say, for example, the asset or the product which the entrepreneur owns is a car. And then now he would put that asset into work and generate profits and then redeploy into the business, back into the business, and then keep growing at whatever the pace, let's say at a nominal pace of 10% year on year or something. So in a classic entrepreneurship, when you have to move from a point 0 to point A, which is 2,000 kilometers, and the asset which you have is a car, it'll take you 3-4 days because your asset will have range problems. It can get a speed of 80 to 100 kilometers, and it needs constant refueling, which is profits being plowed back into the business in business parlance. And so this would take you 3 to 4 days in reaching the first destination and so on and so forth. But let's say the other way to get the working capital needed would be to, since you have an asset, this asset can be pledged, and then a certain amount of debt can be raised, which can be again redeployed into the business, and then the business generates profits and so on and so forth goals. But the other thing, let's say this from classic entrepreneurship stage, this was a slide, right?
Yes, that's correct.
Yeah. So like I said, classic entrepreneurship. But I hope you heard about the bits where I was talking about classic entrepreneurship, that how profits are plowed back into the asset, and that's how a classic entrepreneur regenerates his profits and everything. So was it clear there, or should I go back a little bit?
Yeah, that was covered. Covered.
Okay, great. So then I was talking about when the business grows and then it becomes big, then you actually accumulate a lot of debt. And then I was mentioning that, Reliance industry, Mr. Mukesh Ambani raised more money during lockdown than any other person. So I was explaining that, that kind of capital, which comes from a different kind of investors who are called private equity investors. And then those investors back certain kind of businesses which have stable cash flows. And, they give you what is called in a jet fuel, which help you reach from point 0 to point A in less than 3 hours, because that's the amount of time it will take when you travel in an asset like, let's say, aeroplane. And similarly, the other kind of funding which you see is the venture capitals backed growth. And then the parlance which I want to give you is, when you're trying to build a rocket, the idea is that, this would the classic entrepreneur would take 2 to 3 days to move from point zero to point A, but a private equity backed company would do it in 2 to 3 hours. Then the VCs think, why waste time? We can actually do the distance in less than 30 minutes. And then they give you this kind of fuel, which is actually a rocket fuel, where you go to the market faster, and then like Asha said, fail harder and then come back. So what VCs give you is rocket fuel, but one has to understand the burn in a rocket fuel is much higher, stronger. And the thing with rocket fuel is that the success rates of rockets is also, as you know, if everything goes well, they go into the orbit and everything looks great. But if things don't go well with the burn, they would blow up mid-air. So as an entrepreneur, when you're looking at your business, whatever, you should really understand what kind of business are you building. If you're building a technology business which can scale very faster, and market share is the thing to aim at, then maybe you're probably looking at rocket fuel. But if you're a classic entrepreneur who wants to grow sustainable business, build business and then plow back the profits and then go a long distance. So you need to understand that you're not looking for rocket fuel, or neither you're looking for jet fuel. You're actually looking for fuel from your local petrol station. It could be bank, it could be friends of yours, or anyone who are willing to lend to you. So one has to really understand what is the fuel which is needed for your business, and then appropriately you should understand whether VC's money is right for you, or the private equities, or it's on your friends and families, or the bank. So coming back, we were earlier working in the same field, which is the solar energy field. We were building these products of structures which on which the entire asset is mounted. So we basically design, manufacture, and also go and install in the field all these structures. So we have two companies, one by the name Sundrag, which actually manufactures all these components, and then the other company called Milliamps Energy Solutions, which is the service arm of the business, which actually goes and deploys these all structures in the field. I'll not go into much details. You can look it up on LinkedIn. Do reach out there. Like I said, one is the idea. For us, the idea is this domain in solar energy. And the second is the team. 1.1 and 1.2 is what we are discussing. So 1.2, as you can see, this circular phase is people, ex-IIT, Kharagpur, ISB, people who are the backbone of a company, the strength. So handling different things. Each one is handling different parts of the job. So a solid team is also what is needed for you. Like Dr. Ponson also gave his views. So is what is needed as an entrepreneur. You have to attract talent and then keep them and then move forward. So the third thing, the third keyword is opportunities. A lot of people have already discussed opportunities, but again, let me give you the context on how you should look at opportunities. Let me share this story with you. This is a story of an oil spill. Exxon Valdez is a ship which had a huge oil spill in Alaska. And Alaska being a colder climate, what happened from a regular oil spill is that, let's say a BP oil spill or someplace else, the oil would either float on the surface of the ocean, or it would form. This is what the experience said. That it would either form lumps and then go into the bottom of the ocean, or it would be in a semi-solid state and either be little submerged in between the two states. But the problem with the oil spill near Alaska was that since it's been colder climate, it formed a thick chocolate mousse kind of a semi-solid state. It was floating on top of the ocean, and it was not in a liquid state, so that the oil industry experts could have burnt it, evaporated, and removed that from the ocean surface. And they were breaking their head for a decade on the solution. How do you remove this oil floating on ocean? And surprisingly of all places, the solution came from a civil engineer who faces a similar problem when concrete comes from a certain distance to him while he's actually concreting a slab or a column or a beam. So he would get it in a sort of semi-solid state, and then for him to make sure that it goes to any nook and corners of, so that it's properly concreted, all the structural members are properly concreted. So what we use is an electric vibrator, and then make that concrete again flow again into each spaces. And when this idea was thrown open to the public, the one who gave the solution felt that this was so cliche of option. The oil industry experts and the scientists must have already thought about it, but then surprisingly he receives a grant saying no one thought about it, and then they used a sort of slightly modified vibrator and then made that mousse kind of thing into oil back again. And then again, the way to extract oil out of the ocean is a very difficult task, but then they went on doing that. So again, much more context building. This is again ex-IIT Kharagpur people starting this company. Pawan is a mechanical engineer from IIT Kharagpur, worked in ISRO, and then his co-founder worked in ISRO. They were building engines for ISRO, the launch vehicles like PSLV, GSLV. They have come out, and then they have started venturing into cryogenic engines, which are used for smaller satellites to put them into space. And this, so again, these are examples of classic engineers working in one domain and then coming out of the domain and then trying to build a business, grab an opportunity, and take it further. Similarly, I'll give you other KGPN examples. Again, Siddhant and Pankaj are co-founders of this company called Quant Solar. Both are ocean and naval architecture engineers, worked in Singapore in the similar field, and then they have decided to come out and work in the same field. Again, these are classic engineers working in the same field. Like I explained, these are solar solutions on water bodies. And these are again another company, example of another company, civil engineers, but here they are using technology as a solution to solve a problem in the world. For example, all the equipment which we use in construction, they are very heavily capex in mode. Each construction equipment, certain kinds of, are in excess of 1 crore or something in asset price. So the revenue generation of this asset is actually when it is deployed in the site, and the payback or sort of return on investment is higher when these are deployed continuously. So this is a company which is just using technology as a solution. It's onboarding all the equipments which are there in India, and then it's a sort of like Uber for your construction equipment. If you want to hire let's say a JCB or a crane, you could just go on and then hire it from them. So again, the idea is, in your vicinity, whatever construction equipment is there, they're going to list it and give it to you at a price so that you can use the equipment. And then there are people who are, replacing the traditional facades of building, and then they are using solar modules to completely eliminate and then maybe help produce energy and cooling of the building through this. So the opportunities, broadly, a lot of it has been already covered, but then it works in this broad area of man, machine, materials. Either like Ashay, you're working on the materials, innovative materials, and then trying to get it, or you're working on machines like automation, 3D printing, which he explained, which can come up a big way in construction, or on the way man or manpower is used. How can you make it more efficient? How can you make planning using technology, using photographing, AI, machine learning? How can you plan better? How can you complete a project faster? So these are the broad areas which will be there. But then again, context building, which I wanted to give you is the finding the opportunity will take time, and also the necessary preparation and everything. But one idea which I want to leave you guys with is that there is a preparation which is needed before you take on an opportunity. So and one sure way is to have your preparation ready, so that when there is an opportunity available, that when preparation meets opportunity, it's called getting lucky. Luck is just when preparation meets opportunity, like sort of saying, I was at the right place at the right time. So that opportunities will be there, will continue to exist, they will always be there. But then one sure thing which can be in your hand is the preparation. Let's say if you're not prepared enough, and then there exists this opportunity which you want to address, but then the marriage will not happen and the value unlocking might not happen. But what is in your hand is the preparation. And one theory which is coming up, and then more research has been put in, like Ashay suggested certain books. This is a book by David Epstein which is called Range, where he explains difference between a Tiger Woods and a Roger Federer. Roger Federer was never playing tennis early in his childhood, though his mother was a tennis coach. He only later specializes into tennis. So how it works is, there is a sampling period which happens where you try a lot of disciplines. For example, Roger Federer tried basketball, swimming, all other sports except tennis. And then once he found that tennis is what he likes, and then he eventually specializes in it and puts in all the effort and grows. So this is a preparation which is in your hands, where over the years, this is what the research is pointing out, that you can be a person who is a core expert in one area, but then you need to also have the range of certain other disciplines that you are equally qualified enough to know about it, but maybe not a master of it. So you got to be a jack of all and master of one, which is in your hands. And then once your preparation is there, the opportunities are always there, and then that value unlocking will happen. So, and again, this is all individualistic. So like I said, entrepreneurship is not one's individual thing. So this jigsaw puzzle piece, which looks like it, when you have your co-founders and the other team members who are equally competent, who have equal range and also an expertise in a domain which is not the same as yours but complementary, so that when all the four of you or the entire team comes together as a jigsaw puzzle, all pieces are unique and they have their own expertise and range. And when they all come together, then this bigger picture of a very coherent masterpiece comes out. And any opportunity which you tackle then, or any idea which you work on with such a kind of a team which has complementary skills, great range, and well-defined expertise, each one is defined in their own area of expertise. I think that's where great value unlocking happens of opportunities. So in conclusion, let me conclude. See, no one can give you an opportunity on a platter and then say, please go get it, because each opportunity actually appeals to each individual differently. So whatever appeals to you, in conclusion, I would say that the entrepreneur in you, he will find the opportunities to be solved in the world. Either he'll use civil engineering, or he'll use a mixture of disciplines, or juxtaposing different disciplines, or by pure serendipity he might solve the opportunities. But one sure way is to know your preparation, and opportunities are always there. And then just preparation meeting opportunity, you're unlocking value. And then that's the story of an entrepreneur.
Professor Sen, you are mute.
Okay. I think it was a great learning experience from different speakers today. And it was also, of course, I would like to first thank Dr. Laurent for a nice presentation, because the rest of them I know. So you are the only one which I'm meeting for the first time. And your background is civil engineering? I didn't know that.
Yeah, actually, it turns out I'm a physicist, and I have to say I really enjoyed the last presentation. I think I forgot the point. Pluridisciplinary now is a standard. It's not anymore like back in the day. Okay, the standard now is, so I'm a physicist. I moved to mechanical engineering, civil engineering, turn around all these domains.
Okay.
Yeah, that's my background. Yeah.
Okay, that's great. So when did you start this Tortoise company?
Yeah, Tortoise was founded in 2017, but I would say really started 2018. In French, we have this system of very academic system where we have to get a prize to get some kind of fellowship from French government.
Okay.
And then you can say it really helps you. I guess there is stuff like that in India, but we got this big prize in 2018 that allow you to launch really the company and hire people.
Oh, great. So it was a very nice talk, and merci beaucoup for that. And
Merci. Merci.
No, Professor Sen, you're mute again. You're mute again.
sorry. Okay, so coming to the rest, the other three speakers, if I talk of seniority, Dr. Dubey comes first. So very nice presentation. And means there are a lot of things which I also didn't know. Means you said you had been working on waste recycle or on the topics of waste management for last 20 years. So that's a great deal of time. So and really means these days, as you showed, really this waste disposal itself is such a big problem. And of course, although you are not an entrepreneur yourself, but I think you showed a lot of opportunities which can be found from waste. So thanks a lot for your great talk. And then coming to Ashay and Venkatesh, so both of them I know very well, in fact. So it's nice seeing them after a long time, of course, virtually. But being virtually, I can see them. Otherwise, they are so far away. Ashay is in US. I don't know where Venkatesh is. Where are you, Venkatesh?
I'm in Mumbai. I'm in headquartered in Mumbai, sir. So right now I'm at home, working from home, sort of.
Okay. So, but your work involves going out, maybe venturing out of home. So how?
Yes. So right now I'm in Hyderabad, but then yes, I'm traveling again to different places across India.
Okay.
Starting next week. Yeah.
And even Ashay's
so
work.
Right now
sorry. Yeah.
Sorry. Right now I'm in Hyderabad. So yes.
Right now you are there, but the kind of work you are doing, it's great work, but that involves a lot of movement from going from one place to another. Yeah. So. And even Ashay's work is very interesting. This paint thing really means it never occurred to us. So you are the patent of the paint is you developed by your team, or?
Yeah, so yes, it's me, my co-founder, and my PhD advisor. So the three of us, we developed the technology.
Okay, great. So but that also might be requiring means it's not work from home mostly, right? Means you have to.
Oh yeah, I mean it's constant. The good thing is that because we are a small startup, the team is small, so we can still assemble in one place and we can work from there. So we have a lab space here in Phoenix, Arizona, and then we have some commercial pilot projects in the US and in Europe going on.
Okay, so even in Europe, so you come all the way across the Atlantic.
Oh yeah, I mean it's just that there is a big, huge boom in clean tech these days, and Europe is actually much ahead of US in terms of reducing their carbon emissions. So that is where the bigger opportunity is, and US is like the home base for us right now.
Okay. So all the talks were very good, and there was a common photo which Venkatesh showed us, in which Ashay was there and Venkatesh was there as well. So I think you can share that with the present Megalith team. They will upload that on their Facebook. So I think it's very interesting to see older Megalith people. Of course, So that was a very good nostalgic moment. And of course, I learned so many new things. Of course, I don't know if it is time for me for starting any entrepreneurship, but at least I learned so many good things.
One point I wanted to say on that photograph, sir, that, back then we used to look very young, but then we cannot say the same. Me and Ashay now look completely different, but you look the same. That's what we have to say over the years. You're only getting younger.
No, you have aged definitely, but you have also become wise, because you have become wiser with your experience. So it's unlike your student days and what you are now. I think Ashe passed out in 2013, Venkatesh in 2014 or 15, I think.
Yes.
So
14.
14, yeah. So it is
I
very.
came back. I came back in 2015, so I for my second innings here. But
Okay,
I
you
missed.
didn't need them. You missed
I,
them. That's right. You
no,
missed them.
I say reminded me that I was there. He organized the talk which I gave in 2012.
Okay. Oh,
Yeah,
that
for
time you came
CES.
for.
Yeah,
Yeah,
Okay.
Civil Engineering Society. Yeah.
Okay, great.
yeah.
So
So
it
I
was.
still remember that.
Yeah, it was very. I mean, all these talks. In fact, these new things also are. I believe it would be very important for the participants. And so, thank you so much, all of you, for taking your time and being with the Megalith team. And I think I hand over to the Megalith organizers now. So over to the Megalith team.
Yeah, I just wanted to say, so for anybody who is listening, I've put my email in the chat box. So if you had any questions regarding the presentation, if you want to discuss any ideas with me, please feel free to email me. I know like we probably did not leave a lot of time for discussion, and I have to jump off and get on another call as well. So thank you so much for yeah, Dr. Sen, Dr. Dubey, Dr. Ponson, Venki, and everybody being here. Had a great experience. Thank you so much.
Thank you, Asif.
Okay.
Thank you, Asif, for giving your time for the megalith, and we are also lacking the time, so we can conclude the session now. Because
I think
yeah,
there were a few questions. Actually, I don't know, the questionnaires might have left. So they were posting several questions on the chat box, but I don't know if we could have answered them. But if you, I think the presenters can have a look at the chat box. If you have answers to them, you can probably mail. I don't know if mail is possible or whatever way. I'm not sure, but there were some questions there. It relates to almost all the presenters. I don't know, Megalith people can do something about that.
yes, sir. We have noted. We will do. We will mail and we will contact them.
Okay, fine, great.
And we are running short of time, so we can conclude the session.
Okay,
And
sure. Yeah.
thank you
Okay
everyone
then.
for
Thank you.
Thank
thank
you.
you all the
Okay then.
panelists,
Thank you,
Thank
Dr.
you.
Dr.
Sen.
Sarora,
See
Dr.
you.
Paresh, for the
Thank
time.
you.
Yeah, thank you so much,
And
and thank you, Dr. Laurent, for being with
Thank
us.
you.
Okay,
Thank
It
you.
was my pleasure. Thank you to everybody. Bye bye.
okay,
Bye
bye.
bye.
Thank you.
thank you.